The goal of this video is to introduce the morning surge queue analysis tool from the Stanford-MIT Healthy Elections project. This tool will help model what happens to a polling place that starts the day with a line. It can also be helpful for an expected buildup at the line at a different time during the day, like after work, but we'll focus on a morning example for simplicity. The tool will help you answer how long lines are likely to persist and how long the line may get in the interim. You'll notice many similarities between this tool and the bottleneck tool, as the inputs are largely similar. This tool can also be helpful in identifying the bottleneck of a process, which itself is helpful in understanding where lines will form. And here we assume that the line dynamics are completely determined by the bottleneck. Let's scroll down to the tool and see what it looks like. We have inputs on the left and outputs on the right. The first input is the selection of the system setup. By default, it is a three-step process: check-in, then voting, then scanning. We can also have a simpler two-step check-in voting process or a more complex four-step process that includes a health check. If your process is slightly different, choose the one with the correct number of steps and ignore the row labels. Again, only the bottleneck will impact the results that we'll look through. We'll start with the three-step process as a default. This table down below needs the number of stations and average processing time for each of the three steps in the process. Click into the cell and type in the number for each case. For the arrival rate, let's assume an average voter arrival rate of 40 voters per hour during the day. It's most important to accurately model the few hours directly after the line is expected to build up. In this case, the first few hours of the day, and we'll be able to quantify what the first few hours means in a little bit when we look at the duration of the surge. To start, let's assume that there are 30 voters in line at the beginning of the day, and then click Calculate. The first thing to notice is that there are two columns in the input table that are populated. One says the capacity of each step, and one the utilization. In this case, the orange exclamation point says that check-in is our bottleneck, with 45 voters per hour, which is a lower capacity than the other two steps, and therefore it will govern our rate. Over here we can see the utilization of each step, and the bottleneck will have the highest utilization at around 90%. Over on the right we have four statistics that are reported. First is the duration of the surge, which is the average time that we expect the line will be at the polling place until it dissipates. In this case, about 5.5 hours. In the time between poll opening and when the line finally dissipates, again, on average that's 5.5 hours, but it may be slightly lower or higher. Whatever the dissipation time is, during that time, we're reporting that there's a 50% chance that the line will reach at least 32 voters, a 25% chance that it will reach at least 38 voters, and a 5% chance that the line will be 52 voters or longer. In thinking about what input statistics most impact these results, the utilization of the bottleneck is one place to look. Let's look at a case where only 20 voters per hour arrive after the line starts to move through the process. 45 voters per hour, which is the capacity of check-in, is more than enough to deal with 20 voters per hour. So when we click Calculate, we can see that this duration of the surge is much shorter and that there's a high probability that the line does not get too long. There's only a 5% chance that the line will get to 30 or longer. You'll notice here that 27 or longer for 50% chance is actually shorter than the original length, and that's because this model assumes that immediately when the polls open, the line drops by the number of stations in the bottleneck, in this case 3. So we open the doors, the line drops to 27 people, and there's a 50% chance that the line will get to 27 or longer after that. This is slightly disingenuous, and it's important to be careful here. There's actually a 100% chance that the line will get to 27 or longer because it's 27 immediately. But when this says that there's a 50% chance, it means that there's a less than 50% chance that the next number, i.e. 28 and longer, will happen. This is the discrete nature of the problem, so it's just something to keep in mind, especially when the numbers are tight together like this, with 27, 28, and 30 for the 50, 25, and 5% chances. If we click the voter arrival rate back up to 40 voters per hour, we can see that the numbers will space out a little bit more and are likely to be more exactly close to 50%, 25%, and 5%. Hope this is helpful. Thanks very much.